Hi everyone, this is Ulrich from Teledyne Devices with a short video about how to acquire nanosecond signals with coexisting strong and weak pulses. Throughout this video, we will examine signals with a large amplitude difference between strong and weak signal components. Furthermore, we will focus on pulses with short duration, for example 1 nanosecond total duration or 600 picoseconds full width at half maximum. First, we need to select the digitizer with a sufficient sampling rate. If the rate is too low, there will be few samples per pulse and the measured signal, shown in yellow, won't accurately reflect the analog input shown in gray. With increasing sampling rate, the number of samples per pulse also increases, resulting in a more accurate representation of the actual input signal. If we, for example, sample a 1 nanosecond pulse using a 5 gigasample per second sampling rate, this corresponds to a 0.2 nanosecond sampling period, which results in 5 samples or measurement values per pulse. The number of required samples per pulse varies by application, but as you can see here, the acquired yellow signal quite accurately reflects the original analog input in gray. The second important design consideration is the digitizer's vertical resolution. Low-resolution digitizers exhibit high noise levels, which can vary weak pulses in noise, making them undetectable. With higher resolution, the noise decreases and the weak pulse is easier to detect. And finally, when using a high-resolution digitizer, the situation improves even further so that the pulse becomes clearly visible. However, when measuring nanosecond pulses, your options are limited by the performance of available ADCs. Here are state-of-the-art 16-bit ADCs from Texas Instruments and Analog Devices supporting sampling rates of 1 gigasample per second and 310 megasamples per second respectively. These ADCs cannot measure our 1 nanosecond pulse accurately, as they would only provide 1 sample per pulse at most, failing to reflect the actual input signal. That's why we designed the ADQ35 PDRX digitizer. This device is optimized for time domain pulse acquisition. It uses an integrated so-called dual gain architecture in order to achieve 5 gigasample per second sampling rate with 16-bit noise performance. That's 5 times higher sampling rate than the ADCs on the previous slide. ADQ35 PDRX also comes with an open FPGA that can be reconfigured with either custom firmware or ready-made application-specific firmware packages. Additionally, it also supports peer-to-peer streaming at up to 14 gigabytes per second to either GPU for post-processing or SSD for recording to disk. This digitizer is ideal for applications such as mass spectrometry and more. If you're working with periodic or repetitive signals, you can additionally use our FWATD firmware package for real-time waveform accumulation. By accumulating the acquired periodic pulses, you can significantly increase the signal-to-noise ratio and at the same time reduce the data rate. Let's conclude with a real-life mass spectrometry measurement conducted by our German partner 5 Technologies. For this experiment, they utilized a modified version of the benchtop 1 mass spectrometer, and the tests involved serial dilutions with concentrations ranging from 22 nanograms per microliter to 22 femtograms per microliter. This represents a factor of 1 million difference in concentration levels, which is challenging to support even with 14-bit digitizers. The measurements presented here were obtained using 5,000 scans per mass spectrum, but at 260 degrees Celsius source temperature, the performance at the lowest concentration level was limited by the chemical background noise, and we therefore lowered the ion source temperature to 200 degrees Celsius or 392 degrees Fahrenheit. The OFN peaks are clearly visible at all concentration levels, including 22 femtograms per microliter, shown bottom right. This is achieved through the exceptional performance of the PDRX digitizer, which surpasses conventional 14-bit digitizers. In conclusion, the performance of the PDRX digitizer can extend the range of your mass spectrometer beyond conventional limits. Hope you enjoy this short video, and thank you for watching.